This is problem 4.3.29, and we want to find the max or min for this function. F of x is 1 minus 8x over e to the 4x. And we want to check my math lab tells us specifically to check and see if that is a max or min with the second derivative. So first, anytime we want to find a max or min, we find the derivative, because we know that a max or min will happen when the derivative is 0, or when it's kind of flat. So the derivative, I look at this and I realize, okay, I'm going to need the quotient rule, right? Because this is my top and my bottom. And the quotient rule is bottom times top prime minus top times bottom prime, all over bottom squared. So with that, let's see, bottom is e to the 4x times the derivative of the top. So derivative of 1 is 0, we don't need that, minus 8x, the derivative of that would be minus 8, or negative 8. Minus the top, so 1 minus 8x, times the derivative of the bottom. So this e to the 4x. Now when I take the derivative of e to the 4x, I have to use the chain rule in here. So I say, okay, this is like a little box here. Now e to the x is always still e to the x, so it's going to be e to whatever was inside the x, stays inside the box, stays the same. Times, and now I need the derivative of what's inside the box, so the derivative of 4x is 4. All over the bottom squared, so e to the 4x squared. Now at first I looked at this and I thought this is going to be a pain to try and set equal to 0 and solve. It's going to be very difficult. But it's really not that bad. Because notice when you look through, what do you see here? This piece term has an e to the 4x. This piece has an e to the 4x, and this piece has an e to the 4x. And as long as you do it to every single term, we can go through and cancel out an e to the 4x. And so now I'm left with a negative 8 minus 4 times 1 minus 8x all over e to the 4x. Because once again, I divided each term by e to the 4x. Let's see, so this is going to be negative 8 minus 4 plus 8x all over e to the 4x, or f prime of x equals negative 12 plus 8x. Oh, I skipped a part there. I skipped 4 times 8, so this should be 32x. So negative 12 plus 32x, all over e to the 4x. So again, if we want to find where we have a max or min, we set the derivative equal to 0 and solve for x. So negative 12 plus 32x over e to the 4x equals 0. Normally, in a situation like this, we would multiply both sides by e to the 4x. Now, e to the 4x, e to any power is always positive, so multiplying or dividing by a positive number isn't going to change our sign, so we don't have to worry about that. So let's just multiply both sides by e to the 4x, and 0 times anything is still 0. So we get negative 12 plus 32x equals 0. 32x equals 12. X equals 12 over 32. I could divide both of those by 4, so 3/8. So 3/8 is my critical point, or my critical value. It's where I might have a max or min. I'm not guaranteed, it's just a might. Now I'm actually going to use this as a chance to review both the first derivative test and the second derivative test. Okay. So if I was to do the first derivative test, so I think it's probably been a long time, I think our book prefers the second derivative test. I say, okay, here's my 3/8, and that's my critical point. That's where I might have a max or min. Then I want to test the point on either side. I'll test 0, that's an easy point, and I'll test 1. And I just plug them into my derivative to see if it's positive or negative. So f prime is negative 12 plus 32x over e to the 4x. So f prime of 0 is equal to negative 12 plus 32 times 0 all over e to the 4 times 0. E to the 4 times 0 is 1, 32 times 0 is 0, so this is negative 12. So this is negative, and so we'd be going down. Okay. And at 1, f prime of 1, this is negative 12 plus 32 times 1 all over e to the 4 times 0. Okay, you can put this in your calculator real quick, but I know e to the 4 times 4 times 1 is going to be positive, and negative 12 plus 32, that's 20. So this is 20 over e to the 4. You can put it in your calculator, but I can already guarantee that that is positive. So I don't even need to figure out exactly what it is. I know that it's positive, and so I'd be going up. So based on the shape of these arrows, I'm going down and then up, so this must be a minimum. I usually find that easier than calculating the second derivative, but the second derivative test is a little bit simpler. You don't actually have to plug in the numbers. There are two numbers into the first derivative. So let's go ahead and do it with the second derivative test. And it turns out that we're going to do the exact same thing here that we did to find the first derivative, because the whole format looks almost exactly the same as what we started with. Okay, so we're still going to do quotient rule to find the second derivative. Okay, so we do bottom first times the derivative of the top. Derivative of the top is just going to be 32. Minus, take the top and times it by the derivative of the bottom. Now derivative of e to the 4x, we said is going to be e to the 4x, but I have to times it by the derivative of whatever's inside this, so 4. All over e to the 4x squared. Now if you weren't quite convinced by my magic up above when I simplified those e to the 4x's, I could say, well, let's go through and simplify this and factor out an e to the 4x. So I could factor out e to the 4x, and I'd have left 32 minus, and I'm going to go ahead and, well, maybe I want to multiply, minus 4 times negative 12 plus 32x. All over e to the 4x times e to the 4x, because that's what e to the 4x squared is, right? Now I can clearly cancel out one of those e to the 4x's. So I'm left with 32 minus 4 times negative 12 plus 32x all over e to the 4x. Now at this point you could certainly simplify the top more, and it wouldn't be that difficult. I'm just going to leave it like this though, because my final objective was not to find the second derivative. My final objective here is to use the second derivative to see if x equals 3/8 is a max or a min. So let's just plug it in now. So the second derivative at the point x equals 3/8 is going to be 32 minus 4 times negative 12 plus 32 times 3/8 all over e to the 4 times 3/8. Which equals, putting in my calculator, 7.14. This is positive, so my second derivative is positive. So that means we are concave up, which means it looks like this, which means our point must be a minimum. So no matter how you look at it, x equals 3/8 is a minimum for the function.